I am delighted to introduce our next speaker, Aidan Gomez. Aidan Gomez is co-founder and CEO at Cohere, a provider of cutting-edge NLP models that is solving all kinds of language problems, including text summarization, composition, classification, and more. Prior to Cohere, Aidan co-authored the paper, Attention is All You Need, which introduced the groundbreaking transformer architecture. He also collaborated with a number of AI luminaries, including Geoff Hinton and Geoff during his time at Google Brain, where the team focused their efforts on large-scale machine learning. Based in Toronto, Aidan holds a Bachelor of Science degree in computer science from the University of Toronto and is currently a doctoral student of computer science at the University of Oxford. Aidan is joined by Alexandr Wang, CEO and founder at Scale. Alex, over to you.
Aidan, I'm super excited to be chatting with you today. This will be a lot of fun.
Yeah, likewise. Thanks for having me.
Of course. Well, I figure we'd start with sort of your origin story, let's say, or where your interest in AI started. So obviously you've been interested in AI and NLP for some time now, and one of the co-authors of the original Transformer paper, Attention is All You Need. And so, I'd love to just hear from you. How did you get interested in AI? How did you get pulled in? What excites you about the technology? What has continued to excite you about the technology? Tell us about where it all came from.
Yeah, so I think like a lot of people inside and outside of computer science, AI is kind of like the coolest project that you can be working on, in my opinion. And so I was always fascinated with it, always enjoyed like whatever movies or books incorporated it in. And when I was going to undergrad, I just happened to go to my local school, which was the University of Toronto. And it turns out that was kind of where deep learning was born in some sense. So that's where Geoff Hinton taught. And so I was just steeped in an environment that was at the cutting edge of deep learning and AI and that whole revolution that happened. So like as I was going through my undergrad, I started getting involved with the ML group at U of T, started doing research with Roger Gross and Geoff. And then, I did the Transformer paper at Google, and the rest is history.
So, folks often have different sort of routes into artificial intelligence and why they're interested in it. Some folks, maybe the origins are more come from neuroscience. Some people, their interest comes more from sort of like the mathematical background and sort of like being excited about the sort of like mathematical origins. Other folks maybe come from more of a, computer purists sort of belief around just sort of like the magic of computers. Which of those camps, if any, would you put yourself in?
Yeah, I think it's more the mathematical side. In undergrad, I got really into this book. It's by Roger Penrose. It's called The Emperor's New Mind. And it talked a lot about kind of like he's obviously like a famous mathematician, physicist. And so it talked a lot about a mathematical basis for artificial intelligence and consciousness. And so the very first thing that I wanted to do in AI was actually model the distribution of the primes. I was like super obsessed with number theory, fascinated with the primes. And so I immediately turned to AI to do some sort of analysis. And I brought this up to the profs in U of T when I was like a second year. And obviously that's a bit of a ridiculous idea. So they very politely reoriented me towards more productive efforts. But yeah, I think for me, like the entry point was through maths.
Yeah, super cool. Well, so you spent some time obviously in research and sort of working on AI research at Google Brain and other organizations, and then now you're sort of working on bringing a lot of that technology to a lot of practical applications. What have you noticed are some of the starkest differences between sort of the two modes or the two sort of communities and ways of being?
Yeah, so I think both move at like a staggering pace, like very high intensity. Some people think of academia as like a slow, you just sit and think about ideas and things happen slowly. It's not like that at all in AI. That was definitely not my experience. So their similarity is in the pace. I think that for me, what drew me away from academia and towards industry product is the collaborative nature of the work. So in academia, it's a lot of work by yourself or in small groups. Like you don't usually go beyond 5 to 10 people. I think what's so exciting about working in industry is taking on much larger projects that just require tens or hundreds of people to accomplish. And so that kind of that feeling of being a community, working on a problem, trying to solve it, I found myself way more engaged and excited in that environment.
Super cool. Well, I wanted to ask you a question about again the Transformers paper and Transformers in general. I think obviously now looking back, the insight of Transformers have been a critical enabler for a huge amount of technology. So much so that it was. I was recently in a conversation with Demis, where sort of this conversation of like, had we known how important Transformers were, maybe we would have approached the rollout and sort of the technology quite differently, rather than sort of just sort of releasing it and letting and sort of almost nonchalantly sort of giving it to the world. When you were working on it at the time, I'm curious, and the answer could just be this is like a really interesting question. Like, did it feel monumental? Did it feel like extreme, like critically important? Did it feel like just any other research project? What was sort of the magnitude of the insight at the time, and then how is that your thinking around that evolved in the years since then?
Yeah, I think that I don't want to downplay the significance of the work, but if we hadn't have released it broadly, openly, I think if it weren't for Transformers, there would be something else that came up that would look quite similar. A lot of these ideas of like attention mechanisms and autoregressive models had been in the air. And so I think it's great that we put it out there. And I think that certainly on my part, like there was little to no prescience. Like I had no idea the scale that it was going to be. I will say that the night we were submitting the paper to NeurIPS, Ashish was there telling me this is going to be huge. But I was the intern on the project, and I was like, yeah, we increased Blue by 2 points. I don't really know what that means. It sounds good. So I had no real understanding of the impact. But part of me does feel that it's coincidence, and it's just like the community consolidating around an architecture and just building up an ecosystem of tooling which supports much more rapid iteration on axes like scale, domains, modalities, that type of thing. There's just been so much infrastructure built on top of the transformer that's let it become like the default across a lot of different problems. If it weren't the transformer, I think anything that saturates compute in the same way as a transformer, that makes use of the hardware in the same way or to the same degree that a transformer does will likely perform comparably. So I don't want to downplay the significance. It's fantastic that this has happened. It's fantastic that we've consolidated on this architecture. I think we as a field and community are way more productive as a product. But I'm sure that if the transformer didn't happen, very shortly after, something with a different name, similar look and feel would have popped up.
Yeah, this is, it kind of, you bring up like one of these great questions in research and in history, broadly speaking, which is like, these incredible moments in, let's say, any field of science, or these incredible discoveries, were they path dependent on the individuals who discovered it, or was it sort of more of a, an inevitability given the sort of like, almost as you said, like the ideas that are in the air. And it's always such it's an interesting thought experiment, right? Because take calculus, for example. Calculus was co-created, very similar timing, by Newton and Leibniz, and almost every discovery has some sort of similar origin. There's like right now there's this infamous CRISPR sort of legal battle that's happening in the same way. So it's sort of a very humble perspective that you have, that hey, if not for literally transformers, something else would have occurred in short order. But I do think there is, part of the beauty of transformers is sort of this like grand unifying component of it, which is that now every state-of-the-art model uses transformers, and I don't know, personally, that's one of the most, I also come from a more mathematical background, and that's always the thing that tickles me the most about it. So, but it's a good insight that it's more about the sort of like computational utilization component of the technology.
Yeah. I think the simplicity is really the key, and I think that's that generality that kind of emerged from cutting away all of these domain-specific components. It lets it be applied in way more places, and I think that because so much infrastructure has been built for it, you can suddenly get SOTA over here in images and video and audio, on this task and that, just because the whole community is consolidated on this one architecture, optimized our systems so much for it, that you can just squeeze out performance from it a lot more easily.
Totally. And then obviously since then, people have taken this architecture to great lengths. You Cohere and others training it to massive scale, all the way up to, I think the biggest ones are something around 500 billion parameters. Well, A, did you expect any of that to happen? B, like, were the results, let's say the original GPT-3 paper, how surprising were those results? Because obviously they're not intuitive. They don't intuitively fall out of sort of the efficiency of the transformer architecture. And three, like, what are sort of predictions of what comes next?
Yeah, so on the scaling piece and predicting that, so Noam Shazir, like before any of this scaling, before the first GPT paper, before the transformer paper, he's been pushing on an effort to scale up language models in general for a long time. And so he's been thinking about that for ages and has called it out as something that's important for a long time. And so I had heard that idea well before the GPTs came out, but the actual results, like the output, the product of actually pursuing that effort, it was a total shock to me. Like unsupervised learning is the most scalable, right? Like you don't need any human labeled data. So it's very easy to collect massive quantities of it. And the fact that if you train a model in that environment, it learns to pick up all of these subtasks and generalize to like brand new tasks. It's so shocking. Like I was totally taken aback by that. I definitely, like in terms of what comes next, I think these big models trained on unsupervised data are good, they're amazing, it's impressive, but their performance isn't enough to go to production. Like you can't build a prod-ready model off of them, you need to go further. And so I think the rest of the way to getting this stuff out there, it's work at the product level. And so what sort of interfaces do we expose so that more people can use these models? How do we improve their performance on an arbitrary task that someone's trying to solve? How do we incorporate humans into the loop to improve their performance? All of these like product level questions around how does like the average developer make use of this breakthrough, these large language models? I think that's the area of like highest impact of exploration.
And building off of that, like what are some of the practical applications of the technology that you're most excited about, or that you think the most about right now?
I think there's two that come top of mind for me. The first is like creative applications, like using large language models to create more immersive or like personal worlds in gaming. So those sorts of like world building, world craft applications. Another area is like pro-social technology, basically making online social spheres healthier, less extreme, more balanced. So I think those two require very deep conceptual or contextual understanding of language in order to achieve. You need to have a lot of context about the world. You need to understand not just the meaning of the individual words, but the sentiment that's in the phrases being spoken or the posts being posted. And so I view those as two like really high impact, very different, but very high impact applications.
And what are sort of super interesting, like, yeah, world building for games and sort of like more generative, more creative, more generative, sort of like worlds for, most people spend a lot of time in some form of a digital world, as well as sort of, these safer, better online communities. What are some of the near-term developments that you see down the pike that you think will be most applicable in these areas, and sort of like maybe sketch or walk us through what you think the sort of what you think is possible?
Yeah, I think in order to drive adoption more broadly and to support not just these two use cases, but pretty much any use case, like for Cohere, we're really thinking about the interfaces onto the tech. The easier it is to use this stuff, the more people are going to be doing it. And if you think about an AI expert training a large language model or a transformer, there are like hundreds of different routes to the same solution. Like there's so many different knobs you can turn to optimize performance, that type of thing. But almost all of them require high expertise and like a deep understanding of the underlying tech. We want to like abstract that away. And so I think in order to drive adoption, in order to see this tech start to pop up in places like gaming, like in social media, it needs to become a piece of every single developer's toolkit. And to do that, like there's this big exercise or this big effort we need to undergo in complexity reduction, really stripping away the unnecessary parts, making stuff intuitive, and just getting to a place where any developer, like a high school student, right, like learning to code, can pick up an API and start deploying large language models for the app they're building, and like spotting opportunities within product for how they could incorporate this stuff. If it's not in all 30 million developers' toolkit, we're going to be bottlenecked by the number of AI experts, and there always has been, there is, and I think there always will be a shortage of that talent. So yeah, I think in order to see this tech out there in the real world, in products, it's about figuring out the right interface to put in people's hands.
What do you think, what do you think that enables in terms of end use cases? Like, for example, how would you compare what a video game world could be in the future, or like, let's say, enabled with this technology versus now, or what could be possible in a social community with this technology versus now? Like, bring it to life a little bit. What does that look like?
Yeah, I mean, you can imagine talking to a game character and asking them about their life, which is something that you just don't have the option to do right now, or it's very hard to. You have to write a script today, all the different dialogue trees and paths. Maybe for one character in a Skyrim-like game, maybe you have a dialogue tree that goes 5 layers deep. What does a dialogue tree with 1 million layers look like? How do we build that? How is that scalable? It demands this tech. That world is just so much more engaging. I think that user experience, this is on the gaming side, but that player experience, user experience, is just so much nicer and more rewarding, more natural. The same sorts of improvements to user experiences will come with smart features appearing in products. So much more intuitive search, like dialogue as an interface. I think breaking through that barrier of the status quo today, which is if I want to implement, let's say a smart search feature. Right now, your options are essentially hire someone who's an expert at search, or take an off-the-shelf solution. So you're either hiring a ML expert or you're buying an off-the-shelf solution. There's no option to deploy your existing developer team to go build that. And so I think that gap, it needs to be filled. We need more people capable of doing this because there's not enough MLEs.
Totally. What do you think of? So I think those are all very compelling. One topic that is, I'm sure, top of mind for you as well as most people working on the sort of production applications of this technology, including us, is around bias in data and sort of, how do you protect the potential for unsafe or unexpected outcomes with the technology? How do you all think about that at Cohere, and what approaches do you take to mitigate those risks?
Yeah, so we do a bunch of things at different levels. The first level is with the data. So we try to model the world as we hope it will become, as opposed to just doing a scrape, throwing it into the model, and post hoc trying to fix the model. So ahead of time, we do a lot of filtration on our data. We use the models actually as part of that filtration to identify toxicity or hate speech and pull that out, make sure the model doesn't see that. So the first layer is at the data. The second layer is at the production level, so monitoring what it's being used for and understanding where we start to see misuse and mitigate that. So making sure that it's not being put into production to power Twitter bots, propelling some ideology, that type of thing, or to generate hate speech. So strong monitoring once it's actually in production, and then a priori, making sure that the model is not absorbing toxicity from the internet, or trying to mitigate that as much as possible.
Yep. Cool. Going back to kind of like putting your research hat back on for a second, what do you think is down the pike? It's clear you're very excited about the sort of practical applications and proliferation of the technology, but from a pure research perspective, in terms of what are the things that we're going to see become possible soon, or the capabilities that we're going to see become possible, what are you excited about? And sort of a corollary, what do you think are going to be the limits of the approaches that we're taking today?
Yeah, the things that I'm most excited about are tool use. So the ability for our models to start using tools out in the world. Maybe they should be able to use a calculator. Like a model shouldn't have to manually memorize the product of two 5-digit numbers. It should be able to just plug those into a calculator, which is way more efficient, and get the result back. So giving our models access to a set of tools that they can make reference to and they can start using, I think is going to be like supercharging for the model in terms of its capability. Similarly, giving them access to knowledge bases, giving them access to search engines like Google or Bing, augmenting them with that knowledge as a resource, so that instead of them having to memorize all of these facts, they can make reference to a live, updated knowledge base. I think that's going to be super impactful. And then lastly, I think it's like the current hot topic is multimodal. So actually starting to generate and model text and images and video and audio jointly in one model. I think that's going to lead to a ton of really impactful creative applications.
Yeah. Well, the last question I want to close on is, in thinking about the productization and application of a lot of this technology, what would you encourage developers and businesses to focus on as it relates to utilizing AI?
Yeah, so I think the most important thing to start standardizing or to make more popular within the business and developer context is incorporating like AI features into how you think about product development. And so educating product managers and product leaders, eng leaders in like where the technology is at today and what can be built, and to start thinking about what applications, what features can we build into our product. I think as a product of this shortage in AI talent, most businesses, they're missing out on a huge opportunity to integrate this tech into products, into their developers' workflows, and consumers are missing out on products that have more magical, intuitive, like smart experiences. And so the start of the fix comes with the product folks making the decision about what's prioritized, looking at what they can do, understanding where the technology is today and where they could insert it, and then building it. I think we need to start making AI a standard piece of every single product. I don't think consumers are going to tolerate dumb products anymore. We need to make them much, much smarter.
Well, that's a great rallying cry. Aidan, thank you so much for this wonderful conversation, and can't wait to chat again about this with you soon enough.
Yeah, likewise. Thanks so much, Alex.